Hello, students. Well, there's a new study that says students will learn more if teachers start paying students to learn. Give them a little bit of money for every standard that they learn. I think it's a controversial idea, but I did want to test it out today. So I'd like to get a helper. Kim, could you come here, please? Now, Kim, I'd like to ask you a high school level chemistry question. Is that okay?
Sure.
Okay. How do you calculate molar mass?
I don't know.
Hmm. You think maybe you know now?
Nah, this is not gonna help me. I still don't know.
Maybe this will refresh your memory.
First, find each element on the periodic table, then get the atomic mass, and finally quantify the mass into grams.
Wow, that was terrific. That was exactly right. Very good.
Can I go to my friend's house today?
Oh, no, no, no. I need you to stay home and do your online learning.
Does this change your mind?
Oh, no, you gotta stay at home.
How about now?
I wouldn't be a good father if I let you play today. You have a lot of schoolwork to do.
Can you lend me a 5?
Yeah, sure.
How about now?
Oh, well, okay. Yeah, you can go today.
Thank you.
Opening. How many moles are in 64.132 grams of sulfur? Does that seem familiar? Well, actually, I asked you to solve that Monday for homework, and a lot of you had the right answer, but the wrong significant figure. So I took off 10 points if you didn't give me the answer in correct significant figures. But enough people had trouble with this that I think it's worth going over today. So please pause the video, try to answer this with correct significant figures, and if you get it wrong, it's okay. I'm going to go over how to do it. Please pause the video now. Okay, we're back. How many moles are in 64.132 grams of sulfur? Before we talk about the answer to that, let me answer a question that some people have been asking me. How do you abbreviate moles? Well, it's very tempting to use the letter M, but M is already reserved for mass. People in physics use M, so you can't use it to abbreviate moles. The abbreviation for moles is probably the worst abbreviation in all of history. It's a terrible abbreviation. The abbreviation for mole is MOL. All you do is you remove the silent E at the end. Isn't that just terrible? Why would you even bother? It doesn't really save you much time at all. But that is the official and agreed upon abbreviation for mole. It's MOL. So for example, if you want to abbreviate 12.3 moles per grams, it would be 12.3 MOL/G. That's how you abbreviate it. And it's all lowercase, and there's no periods. All right. So let's get back to the problem. How many moles are in 64.132 grams of sulfur? First thing you need to do is find sulfur on the periodic table. So we can find the molar mass of sulfur. What is the molar mass of sulfur? So let's find sulfur on the periodic table. There it is right there. Let's make it a little bit larger. Sulfur has an atomic mass of 32.06. And there are some periodic tables that have it a little bit more accurate than that, but it's okay if you're using that number. I'm going to use that number. So what is the molar mass of sulfur? Well, we know that sulfur has an atomic mass of 32.06 AMU, and the molar mass would be 32.06 grams per moles. That means that 1 mole is 32.06 grams. All right, and if you want to abbreviate it, it's 32.06 G/MOL. All right, so let's go back to the problem so we know how much 1 mole of sulfur weighs, but it looks like we have a larger number than that. 64.132 grams of sulfur. So this is how you set up the problem. It's going to be 64.132 grams divided by 32.06 grams per mole. And I put parentheses here just to make the problem a little bit more readable, but you don't need these parentheses. Anyway, when you set up the problem like this, you see grams in the numerator and grams in the denominator, so you know what to do there. You can cross them out. And when you cross them out, there's only one unit left over, and it's moles. And that's good. That's the unit we want to have left over. So I put this in the calculator and I get 2.000374298 moles. And a lot of you on Monday's work just told me the answer is 2 moles. Well, that is kind of right. But when you say 2 moles, it indicates it's kind of 2 moles. And look at all these zeros. It's actually not just kind of 2, it's very, very precisely 2. It's not until I get into the, let's see, tens, thousands, it's not until I get into the hundreds of thousands of a mole that I start to see it's a little bit different than exactly 2. So let's see how many significant figures we have here. For this number, we have 1, 2, 3, 4, 5 significant figures. But for this number, we only have 1, 2, 3, 4 significant figures. Remember that it's the least accurate or least precise number that determines the significant figures for our final answers. So here we have 4. That's less precise than this number. So we're going to have 1, 2, 3, 4 significant figures. So let's see how that looks. 1, 2, 3, 4. So I'm going to write as an answer, the answer with correct significant figures is 2.000 moles, or 2.000 moles. And why do I do that? I'm communicating to the reader. Anybody who's going to look at my work and use my work, they're going to see that it's not just kind of 2 moles. It's very, very precisely 2 moles. To a tenth of a gram, to a hundredth of a gram, to a thousandth of a gram, I can assure you that the answer is 2 moles. And, if you go further than that, you're going to end up with different numbers. But rounding to 4 significant figures, the answer you should have put on your paper on Monday was 2.000 moles to get full credit. Even if you used a more accurate periodic table than the one I used today, the answer should have still come to this. That's the end. All right, I want to give special thanks to Wikimedia Commons for their free use picture of the periodic table of elements. And the joke today was actually written by David Zucker, Jim Abrahams, Jerry Zucker, and Pat Proft. All right, hope you enjoyed it.